All right, so let's talk about how we write formulas and name covalent compounds. Now remember, covalent compounds are made up of all non-metals. They are all missing electrons. They all want to get to their octet, but they don't have enough electrons. When we did ionic compounds, we knew that we were going to have a metal who gave up an electron or electrons, and those electrons went to the nonmetal and gave the nonmetal the electrons it needed to get the octet, and it gave it a negative charge, which made it attracted to the positively charged metal. That's ionic. We aren't going to be dealing with that now. We're going to be dealing with just nonmetals who need extra electrons, but they can't get them, so they have to work together and cooperate. So they can be very creative in how they bond. And we're going to be looking at lots and lots of combinations of the same elements, basically. Look at these examples down here. NO, N2O, NO2, N3O7, N2O3. It's all N's and O's, all these examples here. But they're bonded in different ratios. So we're going to have to use prefixes. This is kind of new to us here. We didn't use prefixes for ionic because you're not supposed to. We only use them for covalent bonds. So we're going to start using them now. We use prefixes because those atoms can bond in many different ratios, and the prefixes are going to tell us how many of each one of the atoms are in the formula. For example, I bet you know these first two. This is carbon dioxide. The di told us there's two, dioxide. Two oxygens. We still write oxide, but it's di telling us that there's two. CO is carbon monoxide. And the mon tells us that there's just one oxygen. Now here's carbon bonding with chlorine, but because we have two of these carbons, we're going to use the same prefix we used for the two oxygens. Dicarbon. And then we have chlorine here, so we have to add a prefix, hexa. That's a prefix for 6. I'll tell you how you know that in a minute. Hexa, and then we do the same thing we did before. We write the second word, and instead of writing chlorine, we change the ending to chloride. We always do that. We did that for ionic, and we do that for covalent. We write the second word, change the ending to ide. So we're going to be using prefixes. We just have to figure out what these prefixes are. So prefix for number 1. You probably knew already because you knew this has only one oxygen, so it's mono. We say carbon monoxide. That mon means mono. We just dropped the little O there. 2, you probably knew that was di because you've seen carbon dioxide before. So 2, the prefix is di. 3, you know 3 is a maybe a triangle, tricycle, has 3 wheels. 4, sometimes kids have a hard time with this. This is tetra. And if you want a way to remember this, you can think about the game Tetris. All the different shapes are made up of 4 little squares. So tetra is 4. Think of Tetris. 5, you probably know, a pentagon. Penta is 5. 6, a hexagon. 7, some kids have a little trouble with this one. This is hept, H-E-P-T-A, hepta. So hexa and hepta, don't get them mixed up. 8, I bet you know, you just think about an octopus, has 8 legs, octa, octagon. 9, you might have to remember, but it does start with the same letter as 9, nonagon, or nana. And 10, you probably know already, because what's 10 years? A decade, so deca. So there might be 3 that you kind of have to remember, but the other ones you should be pretty familiar with. Now the good news is these prefixes are on your periodic table. Look at that. They've been here all along. So you don't have to worry about memorizing them. It would help if you knew them, but at least you know where to look. Okay, so what are the rules for naming compounds? Here we go. It's nice and easy. You add a prefix to the name of the first element, except if there's just one. We don't write mono for the first element, like these two. There was one carbon. We didn't write a prefix. Not if it comes first. So for this first example, there's only one N. We don't write a prefix if there's only one. But the next one, N2, we have to use a prefix, di. The next one, the first element, there's only one of them, so we don't use a prefix, just nitrogen. The next one, there's three of them, so we write tri. The next one, there's two of them, we write di. The next one, there's five of them. We got to remember what five is, penta, so we write penta. So that's what we do with the first element. We add a prefix, except if there's just one, and then we don't do anything. We don't use mono for the first element. Now let's look at the second element. We add a prefix to the name of the second element, and we change the ending to "ide," just like we did before. Remember we had nitride, phosphide. Remember all these guys? Nitride, phosphide, oxide, sulfide, fluoride, chloride, bromine, iodide, or bromide, iodide. And we're going to throw hydrogen in the mix now. Hydride. We still change the ending to "ide," which, by the way, is different than, I'm going to use a different color here, than hydroxide. Remember, hydroxide is an ion. So these guys are all nonmetals, but hydroxide is a polyatomic ion. Don't get them mixed up. Hydride, hydroxide, and oxide are all different things. All right, in this case, every single example has a second element that's oxygen. That's not always the case, but in these examples, I wanted to show you how many different ratios they can hook up on it and why these prefixes are so helpful to us. So they all end in oxide, but what we have to do is use a prefix to indicate how many there are. So we're going to add a prefix to the beginning of that second element. And if this isn't a huge ordeal, you'll get the hang of this. But if you have like two vowels next to one another, especially the O and the A, usually you drop the one on the prefix. And you've been doing this right along. Like when you said it's carbon monoxide, you didn't say it's carbon monoxide. So for like this one, it's just NO. So it's nitrogen monoxide. We don't say monoxide. The next one, there's only one oxygen, so it's, again, monoxide. But the next one, there's two oxygens, so it's dioxide. So nitrogen dioxide. The next one, there's 7 oxygens. 7 is hepta. So we write hept, and we drop that extra A, heptoxide. The next one, there's 3 oxygens. You know 3 is trioxide. So dinitrogen trioxide. And the last one, 10, is like 10 years, decade. So it's and then we drop that A, and we just go right into the oxide, decoxide. Okay. Now, we're going to flip this around. We're going to be given names and have to write the formulas. Now, remember before with ionic, we had to look at the periodic table, figure out the charge of each. We had to look at them and compare them. And if they weren't the same, we had to do the crissy-cross thing. You don't have to do any of that. All you have to do is know your prefixes. So, for this first one, triphosphorus pentabromide, you just have to know what the prefixes are. Tri means 3. There's 3 of these things. What's phosphorus? P. And there's 3 of them. Penta is 5. There's 5 of those things. What's bromide? Well, it's bromine with the ending changed. So there's 5 of them. That's it. Carbon. I don't see a prefix. That means there's just 1 of them. Tetra. That means 4. Tetris. There's 4 of these things. What are those? Fluorides. What are fluoride? It's really fluorine. Remember we changed the ending to ide. Dicarbon octahydride. Di means 2. 2 of these. Carbon with a little 2. Octa is 8. 8 of what? 8 of hydrides, which is really hydrogen with the ending changed to ide. That's it. There's no crisscrossing. There's no worry about charges. They don't make charges. You just use the prefixes. So hit pause, try these guys out, and then you can check your answers and see how you did.